Hello again, welcome to part 2 of my tutorial series on my inventory system. Probably jumping right into this one because, well, your inventory's not working yet. There's still some more scripts to go over for it to be working exactly as it is in my project. And I realized after I stopped recording the first one that I probably should have gone over all the prefabs so you can see how they're set up if you don't download the project from GitHub yourself and are just following along. So I'll go through those real quick. Some of the armor or the items, the inventory items. If it were armor, then you could give it the armor component and choose which item it is, the item type, give it the sprite, the item count. Something you should know about the item count, because you may run into this problem down the line, is there is a certain prefab that must be in the scene in order to correctly place an object back into the scene when you drop it out of your inventory, and that is the InvItemManager. So it stores a reference to each of the other inventory item prefabs. That way it can just be pulled from and then we'll know what object to place into the world. However, because the stats of, technically it's the stats of these prefabs that are being altered before placing the object in the world. So for instance, it'll have the same stack size as it was in your inventory before you dropped it. So the way I've gotten around this is by keeping the item count at 0. That way, if you ever happen to place any inventory items into the scene, you will have to adjust that item count to something other than 0. And for some reason, when you do that, now that item in the scene will no longer have its value adjusted. If you were to play the game, grab the same item, drop an item, and then the item count gets changed, it would change that item count for every object of that type in the scene. So you can call it a workaround, but it's not a great one. You got the max stack size. Since this isn't a resource or consumable, I'm keeping it at 1. And specifically for armor, they will have a amount of damage reduction by percentage for each piece of armor equipped, as well as specific protection given for against cold and hot temperatures. The same is going to be for both of those. We'll go to consumables. The bandage. These consumables are made to be much easier for designers to create some on the spot rather than having to get real specific with what each consumable does and then having to give it that functionality in a new script. So you select the item type. These are going to be the same options as the armor. Any inventory item, those are going to be the same. Give it the sprite, the same values. The primary effect is where it starts to get different. You can select what survival system this would affect. Of course, I'm not going to dive into that, so this is where you would have to get creative, do whatever you want with it, but you could select 1 or 2 potential effects, or none if you wanted to for some reason, and then how much of the stat it'll change in the primary and secondary effect, as well as a duration. If this is at 0, then it just means it'll instantly be applied to the player and then removed. If it's stackable, then that only really matters if there is a duration. So if this lasted for 60 seconds, consuming multiple would mean if my damage was increased, then consuming 1 might give me +2 damage, and consuming 2 might give me +4 damage. Otherwise, if this was not stackable, then I could never get above +2 damage. You can also set the effects to be permanent. So even if the function is called to remove the power up from the player's PowerupManager, and if there were a function that might remove the effects from the player, that will never be called. So whatever effects it applies will be persistent. You can also change these values to be percentage based, and you might consider attaching that to like the max health of the health component. So if you set this to like 0.5 and checked is primary percent change, then this item would always heal 50% of your HP. Then you can check these 2 boxes here for if the effects always apply or not. There's another thing you could do is maybe you don't let the player use the consumable if they're already at max health, because why let them waste it? It won't benefit them at all. So you could put in a check that makes it so if they're at max HP, then simply they won't be able to. But if you decided, you could check this and make it so even though you had that guard in, it could just get around it. That sounds like I just pointed out that there's no point in having this, but there is certain times where this will be useful. For instance, if you have a power up or a consumable that will apply 2 effects, and one has that condition where it won't apply, but the other doesn't, and you will always want the player to be able to use that consumable so they can at least get the one effect from it. Go to the resources. This is going to be very similar as well, just selecting item type, sprite, and setting those values. Oh, I should check out the player. Got the character controller, which is getting the help of Unity to get the character moving without having to do everything yourself, like moving the object's rigid body. The player controller, which you guys saw in the last video. The player inventory, select the number of slots and hand slots. If you decide to give them more or less, then of course there's some things you'll have to change in code as well as the UI. If they don't line up, then yeah, you'll have to make some adjustments. Give it a reference to the empty inventory item and inventory UI, which is right here in the player. And then the PowerupManager, you don't have to give that anything. For the inventory UI, give that the inventory UI component. We've already gone over that. The last thing was the inventory item manager, but we checked that out in the scene. So now I'll move on to the actual code. Start with the inventory item manager. We're gonna make a singleton out of it, so have an instance, and there'll be a reference in the scene, and we can get this from any other script, and it'll store the list of inventory item prefabs. Just set the instance to this specific component, which will be the one in the scene, and then make sure it will not be destroyed on loading a new scene. And if there is already an instance of this component that exists, then we'll go ahead and just destroy this one. There's the one function, the get prefab for inventory item, so it passes in an inventory item. We look through the list of inventory item prefabs and we compare the item of the prefab to the item that's being passed in, and we'll return the game object, and then that's how you would spawn it back into the world. Next we have the consumable. It has many more variables. Primary effect, that comes from, oh, have I skipped something? I think that's in the Powerup. I should start with the Powerup first then. You've got your primary effects, which we saw that in the inspector, secondary effect, and then it's going to save all the data that is being passed to from an inventory item, specifically the consumable in this case, because it's the only item that's going to apply a power-up to the player. So you give the power-up its values here, and then the power-up is not inheriting from mono behavior, so that's partially why you have to do that. This is just data that doesn't need to be seen or in the scene. Apply primary effect. This receives a PowerupManager. It'll get its current power-up duration and set it to the max power-up duration so that its duration will be reset properly. I had a bug with this for a while that my brain just didn't want to consider that a stack of inventory items, despite seeming like there's multiple items, is still really just one item with a variable in the class that is storing the size of the stack. Because it's still just one game object, this had the duration has to be reset like this, or else even if you keep consuming the same consumable from the same stack back to back, the duration just won't be reset when you consume the next one. And then this is also where you've got to get creative, because this tutorial is not about my survival systems. If you've selected the primary effect none, you don't want to do anything, but if you've selected health, maybe create a health component and mess around with it. You can give the player maybe some regeneration, just simply increase their max health or their current health, whatever you want to do. You could also clarify something other than health, like a new effect for max health specifically. Apply secondary effect. Well, that's the same situation, just replace primary effect with second effect, all that jazz. Remove primary effect. Yeah, you guessed it, it's going to be the same thing, but you're going to want to undo whatever you did with the primary effect that you applied. And then the same is going to be for removing the second effect. Couple get sets: get primary stat change amount, set primary stat change amount, get second stat change amount, and set second stat change amount. Get max power-up duration, a set max power-up duration, a get current power-up duration, a set current power-up duration, a get is stackable, a set is stackable, get is primary permanent, a set is primary permanent, the get is secondary permanent, and set is second permanent. Get the primary effect, set the primary effect, get the second effect, set the second effect, get is primary percent change, set is primary percent change, get is second percent change, Set is second percent change. Get is primary effect always applied. Set is primary effect. Oh god, do I have to read all these off? I think we get the point. There's a lot of getters and setters. Moving on to the PowerupManager, which you saw was attached to the player. This is where the power-ups will be sent to. If I pop back into the consumable, storing a power-up, and then in the mono behaviors on start, this is where the power-up is receiving all of the data from the inventory item. And then in primary action basically means when this consumable is used. If you remember primary action from the player controller that I showed off, then you'll see you can do some checks here in the consumable. Like this is where you would say, oh, if the player's not at max health, then let's go ahead and use this item. And this also explained why in the last video the berries were not able to be eaten, because that check was removed and the player didn't have a hunger bar to be restored. Going to return false because neither of these were set to true. The primary thing is this PowerupManager.add the power up. So again, there's whatever effect you have it set to, you have it do its thing, apply the power up to the PowerupManager, and that's what the consumable is able to do. Also making sure you pass in the PowerupManager. Back here, the PowerupManager is storing all active power-ups. And it also has a remove power-up queue because of the way it loops through the power-ups. You're not able to remove a power-up while it's still in the middle of looping through the list. So that's what that is used for. Make sure it removes all the expired power-ups when the list is no longer being looped through. So on start, make it a new list. On update, we're gonna decrease any and all power-up timers of the power-ups in the list. And then on the late update, if there are any power-ups that were passed to remove power-up queue, we're going to call that function and go remove them. Add power-up, that was being called here by the consumable. Passes it in, checks if it was already applied, where the power-up exists with its index, and then check if the incoming power-up is already in the list. It checks it by comparing both the primary and secondary effects, make sure it is, well, depending on how many consumables you have that are doing the exact same thing, you might have to change this because this check won't be good enough. It might confuse one power-up with another if they say both applied the same exact effects, but one was more powerful than the other. Either way, when this is the case, it'll set it's already applied to true, get the index in the list that this power-up was at, and then if it turns out that the power-up was not in the list at all, then it'll apply its primary and secondary effect, and if either of these are set to like none, then it won't do anything. That's why the option is there. It'll also track how many times the effect has been applied, so that if the effect ever gets removed, it'll be able to properly undo all of the effects that it has applied. Otherwise, it would only ever undo it once, and then you would still have a semi-permanent power-up, and then go ahead and add the power-ups to the list of power-ups. If it is in the list already and can't stack, all we want to do is reset its duration. That's where the get is stackable comes into play. Use the index that the power-up was found at and set its duration to the max. This is also another place where making sure the effect is always applied comes in handy. Apply the effect and then iterate how many times it's been applied. Here with the second effect. If it is in the list and it can stack, then we'll do that. We'll just apply it as normal, then reset the timer. If we go to remove power-up, this gets passed in the power-up, checks if it's permanent, because if it is, then we're not going to bother. Each time the effect was applied, we're going to undo that effect for both the primary and secondary effect. Even permanent power-ups are going to be removed from the list, but of course, because these checks were skipped, then their effect, their stat change to the player won't be removed. And then it gets added to that queue. And then the timer function, that's what was being called in update. Decrement power-up timers, iterates through each power-up in the list, decreases the time it has remaining using time.delta time and its current power-up duration. Then if that duration is less than or equal to 0, it will call this remove power-up function. And here is the apply remove power-ups queue that was in the remove function. This will actually go and remove that power-up from the list of power-ups, as well as the list will clear itself for the next round of power-ups it needs to remove. Check out the armor, which is very similar to the consumable. Saw this in the inspector, all its variables. The primary action of the armor is going to be slightly different than the primary action of the consumable because it's not using the PowerupManager other than our reference for the player, because there is no power-up on the armor. Instead, this would kind of more directly apply its effect to one of the other player's components. And I guess you could do the same thing for the consumable. You don't have to go through the PowerupManager. Why not just directly apply the power-up, but at the same time the PowerupManager helps decrease the durations of any of the power-ups that were applied and then helps remove its effects. Whereas the armor, you'd want the effects it applies to be permanent until the armor is removed, which is why I decided not to use the PowerupManager for it. And that there's nothing here that shows, something is being applied to the player. Throw that line of code in, however many lines here. Maybe you had armor that increased the player's max health, and get the component from the PowerupManager and change the stat values. And the second is just going to undo bonuses that the armor applied with its primary action. The most important part of actually getting to be able to interact with the UI. You have your class DragAndDrop, and it has to inherit from many things, and all of these might be new to you. They're quite new to me. You need iPointer down handler, iBegin drag handler, iEnd drag handler, iDrag handler, and iDrop handler. All of these interfaces will make it much easier for you to be able to mess with objects in the scene using your mouse. You've got a reference to your canvas. As CodeMonkey explains it, this is to make sure that when you move items around, they don't kind of come out of sync with your mouse movement and seem to move at a different pace, because it all depends on the scaling of the canvas. And then we'll use rect transform for the object that has this component applied to it. We get that on awake. This is almost abstract. It's not really meant to be used, but here it's demonstrated all of the potential functions you have at your disposal using these interfaces. You have on pointer down, which is basically just left clicking. On drag, which is when you click and hold and then you drag the item. And all this is doing is getting the anchored position of this object and sets that to the mouse's delta divided by the canvas scale factor. That'll make it seem like it's almost attached to your mouse. On begin drag is at the very, very beginning of the drag. Of course, it's only called once. On end drag, it's just the opposite. At the very end of the drag, it's called. Then on drop is very similar to on end drag. And you have your get rect transform and set rect transform. Now what really matters is the drag drop inventory item and drag drop inventory discard. So the item has the variables reference the player and the inventory UI, and then we'll also get the player inventory from the player, and we'll get the canvas group from this object. Canvas group will help you do things like change the opacity of the object as you drag it around, and also make it so a raycast from the mouse would be able to go through the item that you're dragging around, so that the raycast could hit something behind the object you're dragging around, and that would allow you to then place the items dragging into a different inventory slot. All I'm overriding is the on drag event. So on begin drag, we'll get the other item. Essentially, the other item is the item that the player is currently dragging around, and where this function is being called is on this item, or what would be the item that has this component that's behind the item that the player is currently dragging around. Or no, that applies to on drop, sorry. On begin drag is purely related to the object that's being dragged around. Here is what I mentioned in the first video, where the item gets dropped to the bottom of the hierarchy, so that it's whatever the player is dragging around will appear on top of everything else. Here it changes the alpha and makes sure that the item being dragged around doesn't block raycasts. And on end drag, it'll undo both those things and refresh the inventory visuals to either snap that item back into place where it should be in the inventory, or help refresh the visuals because maybe items were swap. On drop event, this is actually being called from the object that the player drags another item to and then releases the mouse on. Gets the event data. The other item is the one the player is dragging around. It gets the index value of the other item and the index value of this item. Many bools here to check if the whether the first and second item is in the inventory hand slot or an armor slot. Check those things, set the booleans appropriately, and depending on whether it has those components or not, we will get from the player inventory the core inventory, inventory hand, or the inventory armor, and then we'll get the item at that index. Same sort of deal for armor. And here's a check to make sure the player can't really interact with empty items at all. Just checks if the other item is an empty. Don't do anything if they drag an empty to some other slot. As happened here, we're going to do the same thing, but for the second item or this item, check if these items are the same, because this is when we'll attempt to combine the item with the other stack instead of just swapping. This is one of the functions in the player inventory from the last video, combine stacks. Hopefully it's making sense now why it needed all those parameters. It returns if it was successful, because if it wasn't, then we'll want to go ahead and swap. Otherwise, just forget the attempt to swap because they combined. If both items are in the inventory hand UI, again, mentioned in the first video, this is where a lot of those specific cases come in to make sure using the right index, the right list of inventory slots, we will appropriately swap the items that the player was dragging around with the item that they drag that item to. If the other item's in the inventory UI and this item is in the inventory hand UI, first we'll check if the player's trying to put a resource into the inventory hand. If they are, then we won't let them. It's going to do the same thing for armor. If it's any type of armor, prevent them. Here's a check for an inventory hand, and this item being in the inventory, prevent resources from entering the inventory hand slot and armor, and swap the two. This time throwing the second item in first. The other item is inventory armor UI. This item is in inventory hand UI. We're not going to do anything because we don't want armor to be in the hotbar. And then this is just the other way around thing. We don't want armor to be in the hotbar ever. If the other item's in the armor UI and this item is in the inventory UI, then we can swap them just like that, because the check to make sure armor doesn't end up in a slot it's not supposed to, that check is happening in the player inventory. Both items are in the inventory armor. Go ahead and do nothing, because this would mean swapping a helmet in the helmet slot with the chest plate in the chest plate slot. To case that both items are in the inventory UI, just swap them. Finally, moving on to the DragDropInvItem, how you actually get the items back into the world. Get a reference to the player, and then we'll get their player inventory, the list of inventory items, hand items, and armor items. Again, should say slots. On drop event, it's going to do some of the same things. Get the other item and the index of the other item. Determine if it came from the inventory, the hotbar, or an armor slot. Get the inventory item from player inventory using the index that was gotten above. Depending on how the booleans were set, we're either going to grab an item with the index from the hand slots, the armor slots, or just the core inventory. In the case that it is being dragged straight from an armor slot to outside the inventory, then we'll want to make sure the armor's effects gets removed here. Otherwise, it'd be a bug where equipping armor and then dragging it out of the inventory and then equipping it again would continually reapply its effects without ever removing them. Then we have the get inventory item prefab from the instance of the inventory item manager, using that inventory item that we got here, so that we have the full game object, prefab, the model, and set the item count of the prefab inventory item component to match the item count from this inventory item, and everything else will already be matching. Set it there. There's this function, a check for valid spawn point. We give it the item we want to place into the scene, its index, the inventory hand item, if it's in a hand item, an armor item, and these two values are, as you'll see in a moment, related to how high up we want the object to be placed in the scene off the ground. So we get the helper function, there's a get max bounds. Essentially, this helps determine the full size of collider by combining all the colliders of any child objects that are attached to the parent object, because in the case of like my wood resource, there's a bunch of child objects attached to the parent object, and I need to get the size of all those individual child objects stacked on top of each other. I'm getting the total height, or if there's no child objects, then it'll just return the height of whatever the size of the parent object is. Here's a check for valid spawn point, and we get all that data. So the two zeros at the end were the previous height and combined height. If somehow the players manage to drag the empty inventory item to discard it, we don't want to let them do that. Else we're going to check if we place the item a certain distance in front of the player. If there's any collisions there, then we're going to do some extra checks. So the spawn location uses the player's position plus a location in front of them times the minimum drop distance. This will end up with a location just right in front of the player. And then we'll go ahead and make sure the Y value is the combined height because, well, as you saw in the first video, when there are other items in the way, it will instead place the item on top of the item that was already on the ground rather than have them clip inside each other. So it uses this physics.overlapSphere to check if there is another inventory item in the way around the spawn location. It'll return the colliders. For each collider, it'll check if it's an inventory item, and then we're essentially going to get whatever collider in this list of or array of colliders is the highest off the ground is the one that we want. That's why this check here, the first time there's a inventory item, we'll store that as in this obstacle variable, and then for every other collider, we'll check if that one is at a higher Y position, then we'll go ahead and save that as our obstacle. If the obstacle is not null, take into account its height by getting its max bounds, and then we'll take into account its height, and then we'll add to the spawn location that size to make sure the object we place is at least that high off the ground. And then we're going to call this function again, but this time pass in the new previous height and spawn location.y. We're going to do a new physics.overlapSphere, make sure there won't be anything in the way at the new height, and if there will be, then we're going to run it again, but if there's not, then we can go ahead and place that object at the previous height. So here, if there's no obstacle, nothing in the way, then we'll make sure to reduce the previous height from the combined height because we kind of went one too far with the check for valid spawn point. So then we'll go ahead and instantiate it. We have all the information we need, the items, the game object, the spawn location, and we're going to go ahead and use the player's rotation for the rotation of the game object when it's placed into the scene. And then we're going to remove that item from the player's inventory using its index and the same booleans, and then refresh the inventory. And that would be everything you need to get this inventory system fully operational. So again, I hope these tutorials have helped you out. It might not work for everyone, but I'm still very happy with how it's turned out, and these art assets are definitely not going to stick around. That would be a huge problem for me later. One more thing, if you don't like these underscores here in the enumerators, it does not like spaces. So if you really don't like the underscores, you'd have to go back to strings for naming everything rather than the enumerator, or maybe there's a third way I don't know about, who knows. Anyway, thank you very much for watching, and I'll see you in the next video.